In this first question of your Unit 1 test review, we're going to use this diagram to the right or below to answer the following. And A is saying naming a line that contains point C two different ways. So if it's helpful, you might want to highlight. I like to highlight. Here's point C, and this is a line. And if you notice, this is the only line that's going through point C. Okay? There you go. Okay, you can't use this guy right here because that's not a line, that's a red. Because lines have to have arrows on both ends, like the yellow one. The one here, that has an arrow at that end, but there's no arrow at that end. So that is not a line. Okay, so you have to be very careful of that. So the yellow one is the only line we can use. It's the only line that has point C in it. Well, one way to name a line is to make the line symbol, like so, and then pick 2 points on that line. Okay, I'm going to pick B and C. Those are 2 points that are on that line. And you could have picked A and D. You could have picked E and F. You could have picked C and F. There's lots of right answers. Okay, it just has to be 2 points on that yellow line. Another way you can name a line is by using this little tiny letter, lowercase letter written next to the line. Sometimes they're there, sometimes they're not. But all you have to do is write line Y. Again, that's not a point because there's no dot and it's not capitalized. So it's just another way of naming a line. Okay. B says name a line, two different name. What happened there? Name two different line segments that contain point Q. Okay, well, here's point Q. Okay, I know from Q to P, that's a line segment. And when you draw a segment, you just do a segment symbol. And remember, segments have a start point and end point. So there's no arrows on segments. And then you just write the end points below. Okay, I see that Q, I'm going to go Q to U. Q to U is a segment, right, that has point Q in it. Q, U. Okay. Again, if you forget the symbol, just write the word. Like in B, I'm naming a segment, so just say segment, QU. Or if we go back to A, I'm naming a line. You could just say line, CB. Totally fine, totally acceptable. If we take a look at C, it says name two angles with a vertex of L, and they have to be two different angles. Okay? Here's some stuff we did here. If we name two angles with a vertex of L, here's L, that has to be our vertex, meaning L is in the middle. So I'm going to go over here to B. I can go from B to L to another point. I'm going to go to D. So I can name that angle BLD. Now on some of your quizzes, that's really weird. On some of your quizzes, I noticed this. You just flipped it, DLB. Well, that's not naming two angles. You're naming the same angle just differently. So you have to be very specific. You have to name two angles. Okay? So you have these different letters. So it's really important. L is still the vertex, so L still has to be in the middle. So I think I'm going to start here. I'm going to start at Q, go to L, and go to M. That's a totally different angle. So I'm going to say Q, L, M. Those are two angles that have a vertex of L. And then D is asking are points L, T, and Q collinear. So I'm going to highlight those points. Okay, here's L, here's T, and here's Q. Well, if we remember that vocab word, collinear means same line. So are L, T, and Q on the same line? Yes, they are. They're all right there in a row. So yes, they are collinear. Okay, similar questions to that on your test. If we take a look at 2, it says use the diagram to the right to answer the following. It says A, write the vertex for angle 7. Again, when it's asking for the vertex, that's a point, and it's the pointy part of that angle. So I'm going to highlight Here's angle 7. I'm going to highlight the angle that's going around angle 7. The point of that part of that angle is O. So the vertex of 7 is just point O. Okay. B. What? Ah. There we go. B. This is write another name for angle 3. So I'm going to highlight angle 3. We cannot use the vertex method here because another angle, more than one angle, sharing the vertex of angle 3. So you have to use the 3-point method. So I made my angle symbol, and it doesn't matter which one you put first. The only thing is P is the vertex, the pointy part of your angle. That has to go in the middle. So I'm going to name this angle RPQ. You also could have named it angle QPR, and it would have been totally fine. Either one of those two are acceptable answers. Angle P is not acceptable because other angles are sharing that vertex. For C, it says write another name for angle NPM. So I'm going to highlight it. I love highlighting in geometry. I'm going to say angle N to P to M. NPM. Well, you can use, again, we can't use the vertex method because other angles are sharing that vertex, but there is that number there. So you can name that angle using that number. And 1 is the number that's inside that angle, right here. So I'm going to say angle 1. You also could have just flip-flop the first and last letter. You could have said angle, N, P, N. That's totally fine too. And then D. D says write another name for angle 6. So I'm going to highlight angle 6. Okay, again, we can't use the vertex method. I know you're probably thinking, well, no other angles share that vertex, and they kind of do. This angle right here has a vertex of N, so you can't say angle N. We have to use the 3-point method. So I'm going to say angle M, N, you also could have said angle M, N, P, or angle M, N, R, because they're all on that ray that's making up that angle. Okay? And again, you could have said angle PNM or RNM or ONM. Just make sure N, the vertex, is right in the middle of all those angles. Okay. Number 3 says in the diagram below, ray DV bisects that angle. Find X and the measure of angle CBD. Well, whenever you see the word bisects, it means it's being cut in half. Okay, cut in half. Okay, so we have this big angle right here, ABC, and it's being cut in half by this ray, BD. So because it's being cut in half, we know it's creating two little angles that are the same. So I'm going to put arcs in those angles to show they're the same. Right? And because they're the same, in order to find x to solve this problem, we have to set up an equation. Well, to set up the equation, we can say that 2x plus 7 is equal to 4x minus 9 because they are the same. So angles being bisected, those two angles are congruent, so we can set them equal. And then solve. To solve, I just move the 2x over. I get 7 is equal to 2x minus 9. Add the 9 over. I get 16 is equal to 2x. Divide by 2. And x is equal to 8. But we aren't done, because it wanted to know what x is, and we found that. But it also wants to know what the measure of angle CBD is. And if I highlight C to B to D in my diagram, we have to take what we got for x down here, 8, and plug it in for x in that equation. So the measure of angle BD is equal to 4 times 8 minus 9. And when we plug that into our calculator, 4 times 8 is 32, minus 9 is 23. So the measure of that angle is 23 degrees. And without doing any math, we also know that other angle is 23 degrees because they are the same. Go ahead, flip it over, and talk about number 4. Okay, number 4, it says in the diagram below, DB bisects AC. Right, again, we see the word bisects, we think cuts in half. Okay, if AB is equal to 5x minus 12, and CB is equal to 3x plus 22, find x and the length of AC. Okay, well again, if it's being cut in half, and it already marked it for us, we know that these two segments are the same. And if tick marks aren't already there, draw them. I'm going to redraw them. Get in the habit of it. Right? And it said that AB is 5x minus 12, and that CB is 3x plus 22. Well, again, we have the word bisects. We know things are being cut in half. We know those segments are now congruent. So to solve, all we have to do is just set them equal to each other. So whenever you see the word bisects, be thinking set things equal. And then solve. Okay. Move the 3x over. You get 2x minus 12 equals 22. Add 12 over. And divide by 2. When we do that, 34 divided by 2 is 17. So x is equal to 17. And we found out what x is. Got it. Don't move on to the next problem because we still need to figure out the length of something. We need to figure out the length of AC. I'm going to highlight, here's A to C. And you might be thinking, wait a second, they did not give me an equation for AC. But we know what two of the segments are, and we know they're the same. So all you have to do is take 17, plug it into one of them, it doesn't matter. I'm going to plug it into 3 times x plus 22. Okay. I'm going to do 3 times 17 plus 22. When I do so, again, you can plug that in your calculator. 3 times 17 is 51, and 51 plus 22. Again, you can do this all in one step. 51 plus 22 is 73. So this segment right here is 73, which means this segment right here is 73 because it's being bisected. Okay? Well, to get the entire length, we just add 73 together. 73 plus 73. And when we do that, we get 146. That's the length of AC. I know that does not look like 146. These pictures are not from the scale. Okay? Just keep that in mind in geometry. Alright. Next one, we're going to go to number 5. 5 says solve the following equations, leave answer in simplest fraction form if necessary. So it's just basic solving equations. Some review from Algebra 1. You will have problems like this on your test. Okay. First things first with A. In order before we start moving things over and solving, we have to combine our like terms first. So 6 and 3x are like terms, negative 9 and negative 15 are like terms. We can combine those. 6x plus 3x is 9x. Negative 9 and negative 15, when you combine those, give you negative 24. You have to be careful. I see this a ton. We just get into this habit of solving an equation, do the opposite. But if you notice, all these terms are on the same side. 6, 9, 3, 15, they're all on the same side as each other. So when you combine your like terms, because they're on the same side, keep the signs the same. And don't change anything. You only change the sign when you start moving things over. That's what we're about to do. We have to start moving things over because we want to get x by itself. So this is where we want to change the sign to the opposite. So I'm going to move the 24 over by adding to the opposite. 66 plus 24 equals 90. Divide by 9. And then x ends up equaling 10. Done. With b, we don't have to combine any like terms. We can just start solving right away. Again, what I like to do is move the smaller x over. Because we have more than one x in a problem, so we have to get it down to 1x. Okay, so I'm going to move that 4x over. Cancels out. 12x minus 4x is 8x. Now we're back to your basic two-step equation. Move the 15 over. $25 plus 15 is 40. Divide by 8. X is equal to 12. Move on to the next one. We take a look at C. C, we have a fraction equaling a fraction, which is what we call a proportion, which will be helpful later down the road in geometry. It's good to review how to do. Whenever I have this binomial on the top of one of my proportions, I like to put parentheses around it right away. That helps me solve the problem later down the road. And whenever we're solving a proportion or a fraction equaling a fraction, to solve it, all we have to do is cross multiply. Okay? Meaning you start at the top, multiply across, start at the bottom, multiply up across. Okay, so we're going to multiply, color code this, we're multiplying 4 by 5x minus 9. That's why I like to put parentheses, because I'm multiplying that entire 5x minus 9 by 4. So by writing those parentheses, it organizes your work correctly. And multiply, here, we're just multiplying 2 and 12 together. And then we solve. In order to solve, you have to use that distributive property you talked about in Algebra 1. We have to take the 4 and distribute it. And when we do so, we get 20x minus 36 equals 12. How are you doing? 2 times 12 is 24. No. That should be 24. That's a high. And then just start solving. So I'm going to move the 36 over. I get 20x is equal to 24 plus 36 is 60. Divide by 20. And 20 divided by 60 is 3. And last one in this section for D. Again, it's just simple two-step equation. We want to get x by itself, so I'm going to move the 28 over by subtracting it. So when I do so, I do 53 minus 28, which gives us 25. A little bit different here, we have this square as the exponent. You have to do the opposite to get x by itself. And the opposite of squaring is square rooting. I'm just going to square root both sides. Square root of x squared is just x. It cancels out that exponent. And the square root of 25 is 5. So we are done. Next one. Next section we have to classify these triangles based off its sides and angles. I like to focus on the angle first. Okay? So we classify this based off its angle. Here's that little special angle. There's a box in the corner. Whenever you have a box in the corner, that's indicating to you that it's a right angle. And whenever you have a triangle with a right angle, that makes it a right triangle. If we take a look at the sides, I notice this side's 6, this side's 8, this side's 10. All the sides are different. And when all the sides are different, we would call that scalene. So it is a scalene triangle. There we go, right? Scalene. With B, I noticed that all the angles are the same. And whenever we have a triangle with all three angles are the same, we call that equiangular. And if it's automatically equiangular, that makes it equilateral and vice versa. So on your test, if you just have a triangle with all three sides the same, makes it equilateral. Okay, and it shows you here that all three sides are the same, so it's equilateral. But if it's equilateral, it's also equiangular. Okay, they go hand in hand. So if you're writing one, you have to write the other as your answer. Okay, if all the angles are the same, then all the sides are the same. And if all the sides are the same, then all the angles are the same. Okay. For C, I noticed this angle right here, it's 120 degrees. Okay, which is an obtuse angle because it's bigger than 90. Well, if it has an obtuse angle, guess what? It's an obtuse triangle. Okay. And then I take a look at the sides. I notice this side has one tick mark, that one has one tick mark, and that one has two tick marks. Again, if they have the same number of tick marks, then their measurements are the same. So I notice two sides have the same tick marks, so two sides are the same. The third side's different because it has a different amount of tick marks. So I can say that this is isosceles because it's showing me that two sides are the same. Okay. Go ahead and take a look at 7. And similar stuff on your test on Tuesday. For 7, it says for each of the following, determine if the given segment is a perpendicular bisector, angle bisector, median, or altitude. So for A, we have to determine is AC, which is this line right here, A to C, is a median, altitude, angle bisector, perpendicular bisector. Well, I'm noticing AC is cutting that opposite side in half, going through the midpoint. Okay, so keeping that in mind, it's cutting it in half. Which means it's either a median, because they cut things in half, or a perpendicular bisector, because they cut things in half. But here's the thing. There's no right angles. There's no box that's indicating right angles to me. So AC is not perpendicular to that side. So that's indicating to me that this has to be a median, because it's just cutting that opposite side in half. It's going through the midpoint of the opposite side. It's a median. Okay. If we take a look at B, here is B. B is talking about HE. Okay. I'm noticing two things. I'm noticing that this side right here, DF, is being cut in half. I'm also noticing that there's a right angle, which means that it's perpendicular. So HE is cutting a side in half, and it's also perpendicular to that side. So that would make it a perpendicular bisector. Again, we like to use that upside down T to show that things are perpendicular. For the perpendicular bisector, it's perpendicular, so it creates right angles. It's a bisector, so it's cutting things in half. If we take a look at J, J is talking about, or sorry, C is talking about JL. Okay, well, I don't see sides being cut in half, so it can't be a median, it can't be a perpendicular bisector. I don't see any right angles, so it can't be an altitude. So by process of elimination, it has to be an angle bisector. And the reason why it's an angle bisector, and I'm going to use the abbreviation for angle bisector, is because it's cutting these angles in half. I see these angle marks, so it's telling me it's an angle bisector. So whenever you have those arcs and the angles, the segment is going to be an angle bisector. And finally, with PN, I don't want that one. I want to highlight it. No. There you go. With PN, or D, talking about segment PN, I noticed that there is a right angle. Dropping down, it's creating a right angle, which is telling me it's perpendicular. So that means it's either going to be an altitude or a perpendicular bisector. There's only two of those lines that make right angles. But I noticed that the opposite side, the side that's making a right angle with, is not being cut in half. And you look at it visually. This guy's short. This guy right here is much longer. Okay? So they're not equal, which makes it an altitude. All it's doing is starting at the vertex, drops straight down and making a right angle, which means it's an altitude. Okay, something similar to that on your test. If we take a look at number 8, it says in the diagram below, AD is the altitude of triangle ABC. Find the following. A wants us to find the value of x. So again, it's saying that AD, this line right here, is an altitude. And we just talked about altitudes form right angles. Okay? So I know this angle right here is a right angle. And I know right angles equal 90 degrees. Okay? And that same angle, there's an arrow pointing to it, and it's saying it's 4x minus 6. So all we have to do is take 4x minus 6, set it equal to 90. Okay? And then you just solve for x. So whenever you see the vocab word altitude, think 90 degree angles. Okay? And then you just solve. Move the 6 over. Get 96. Divide by 4. 96 divided by 4 is 24. We found x. It's really tempting, and we're really used to doing this. We just see segments here. We see the 2x minus 15 and the x plus 7, and we just think set them equal. We can't do that in this problem because we have an altitude, and altitudes don't cut things in half. They don't pass through the midpoint. So we cannot set those equal to each other. We can only set them equal to 90. That's it. Okay. B says find the measures of CD and BD. Well, we know what x is. To figure out what CD and BD are, we just plug in x. For both. 24 plus 7. And then you solve. You plug x into DB, you plug x into CD, plug in your calculator. And you'll see that once you do that, they are definitely not the same. Because when we plug 24 in for DB, you plug that in your calculator. 2 times 24 is 48. 48 minus 15 is 33. When we plug 24 in for CD, 24 plus 7 is 31. They are very close to being the same, but they're not. Because altitudes don't go through the midpoint. So you cannot set those equal to each other. You take the angle, set it equal to 90. Okay. Flip it over. Last problem we're going to go over on the review. It says in the diagram below, EY is a median. Okay? EY is the median of triangle ERT, this guy right here. And whenever we have a median, okay, it's passing through the midpoint of the side it's going through. Okay? Which means if it's going through the midpoint, it's going through the middle, it's cutting it in half. So I know those parts are congruent. We want to find the following. It says in A, it says if RY equals 2Z minus 1, and TY equals 4Z minus 11, find Z. Well, I know that's a median. I know those parts are the same. Set them equal. And then solve. To solve, all we have to do is move the 2Z over. Add 12, add 11 to both sides. And we're just solving for Z. Negative 1 plus 11 is 10. Divide divided by 2. And z equals 5. Done. So think when you see median, you're setting those parts equal to each other. The last one, if we take a look at B, says, again, we still know that UI is a median. UI is a median. And we know that we just said that those are the same. And it says that RY is 15x minus 1, and TY is 3x plus 23. Again, same thing, we have a median. Set those parts equal to each other. And solve. When we solve, move the 3x over to get 12x minus 1 equals 23. And the 1, we get 12x is equal to 24. Divide by 12. And x ends up equaling 2. Okay? That's what x equals 2. But you have to be careful. It asks for RT. And again, RT, R to T is that whole entire thing. So similar to that one problem we did a few back, what you have to do is just take 2, plug it in for one of these. I'm going to plug it in for this guy right here, RY. And we do so. 15 times 2 is 30. Minus 1 is 29. Okay? That's saying that RY is 29, which means TY is 29 because they're the same. So to get the whole thing, RT, we just have to add 29 to itself. And when we do so, 29 gives us 58. If you need to, watch the video again. Now, go ahead and get started on that practice. Or study more, work on that vocab practice.